Alright, so this is day 2 of performing operations with numbers in scientific notation. And I threw the learning goals up here again just to remind us what we're trying to do. Again, we're trying to perform operations on numbers in scientific notation. I highlighted add and subtract because we've already done multiplication and division. That's what we did yesterday. So you should be pretty comfortable with multiplying and dividing scientific notation. Now we're going to add and subtract. That's what we're going to work on today. All right. So if you're not already there, go ahead and get to M568. And on that page, you're going to see a chart. This looks very familiar because we've had a lot of charts like this where we have some numbers and we need to put them into scientific notation. So that is the first thing that we're going to do. You guys are getting really good at scientific notation, so I don't think we need very long. I'm going to give you a minute to get the scientific notation part done, that far right column. Okay, so you have a minute to get that filled in. Ready, go. Okay, so hopefully your answers look like the ones that I have here on the right of the screen. So starting with Mercury, you should have gotten 5 8/10 times 10 to the 7th. And then all the way down, the last one, Neptune, should have been 4.5 times 10 to the 9th. And a whole bunch of different ones in between. You can check those as needed now. Alright, so that wasn't anything new. That wasn't an addition or subtraction. And on page M569, the first question, we're going to use standard form. So we're really not even using scientific notation to start off with. So it says, use standard form of the distances to determine on average how much further Mars is than Venus from the Sun. Alright, well, first off, we got to figure out what we're going to be doing. What operation we're going to be doing, if we're going to be adding or subtracting. Well, it says how much further in the problem. How much further, that is a sign that we need to do subtraction. We're finding a difference between distances. So what we're really trying to find is Mars, the distance from the Sun to Mars, minus the distance from Sun to Venus. Okay? And again, we're using standard form. We're not using scientific notation yet. Okay? So in standard form, Mars is 228 million miles away. So 228 million miles away. And then we're subtracting Venus, which is 108 million miles away. Okay. And when we do that subtraction, whether you do it on paper or in a calculator or whatever method you want to do, you're going to end up with 120 million. And we know that this is in miles. We always need to have our label. Okay? So we got 120 million miles is our answer there. Okay. Now, question B says, okay, write your answer in scientific notation. All right, we already know how to do that. Just to make sure, quick refresher, our decimal point would be here at the end, and we need to move it 1, 2, 3, 4, 5, 6, 7, 8 spaces to get our mantissa to be between 1 and 10. So our mantissa becomes 1 and 2/10, and that is times 10 to the 8th because we moved it 8 spaces. Okay. So that's all we have to do there. Now C says compare the characteristic. Remember that word characteristic just means exponent. For the distance from the Sun to Mars and from the Sun to Venus, then look at the characteristic in your answer from part B. What do you notice? Okay, so we've got the characteristics, which is the exponent that goes with the 10. Well, over here on the right, I included this. This one is the scientific notation for Venus. This one is the scientific notation for Mars. And what do they have in common? Well, they both have an 8 as their characteristic. That's their exponent. And our answer also had an 8 as its characteristic right there. So that is what I noticed right away when we look at that. Okay? Now what I want you to be thinking about as we go through the rest of this lesson is, was that a coincidence or not? Okay. Then D says, compare the mantissas for the distance from the Sun to Mars and from the Sun to Venus. Then look at the mantissas of your answer from part B. What do you notice? Okay, so from C, well, for C, I should say they're all 8. Okay, and for D, when you look at the mantissas, you've got, this was our mantissa for Mars. This was our mantissa for Venus. And if you do that math, if you do 2 and 28/100 minus 1 and 8/100, you end up with 1 and 2/10, which is what our mantissa for our answer was. Okay. So you guys were probably already picking up on that because we did division and multiplication yesterday, and that's kind of how the mantissas worked for them, was we just multiplied them together or divided them together. So it makes sense that we can just subtract our mantissas here. The difference, though, is C, where the characteristics were the same, and if we were doing multiplication or division, we would either add or subtract those exponents. But here, our characteristic or our exponent just stayed the same. So that's something we got to look out for and see if that pattern continues, and we got to figure out what's going on there. Okay, so you can go ahead and go to the next page, or sorry, no, this is at the bottom of the same page, and it says describe how to calculate the difference of two numbers written in scientific notation that have the same characteristic. That's what we just did. So what shortcut could we have used from the start to not have to write out all those big long numbers for Mars and Venus to do the subtraction? Now knowing what we do know about subtracting numbers that have the same characteristic, what would have been a shortcut? So I want you to write that for question 3 and give you a minute to do that now. All right, so hopefully you've had a chance to write down something. I want you to turn to your partner and share with them what you got for question 3, and then when you are finished, your partner can respond and tell you what they got. So I want you to start with person number 1, partner number 1. Go ahead and share now. All right, so hopefully you were able to share an answer and hear an answer, and hopefully they were similar answers, and hopefully you guys discovered that we can just subtract our mantisas and save us some time, okay? That's only when our characteristics are the same, okay? All right, so now question 4. All right, so on page 70, it asks us to compare the distance from Mars to the Sun and from Mercury to the Sun. Okay? So earlier we did Mars to Venus, and it was Mars subtract Venus. Here it's Mars compared to Mercury. Again, the question is, how much further is Mars from the Sun than Mercury? So we know again that it's going to be a subtraction problem. So let's go ahead and set this up. Again, we're in the standard form, not scientific notation yet. So we know that Mars minus Mercury will give us our answer. Okay, so let's set it up. We already know that Mars is 228 million miles away from the Sun on average. And the chart tells us that Mercury is 58 million. And if you subtract that on paper, or if you do it in your calculator, either way, you're going to end up with 170 million as your answer. Okay? All right. So at the middle of this page, it's got 2 examples. So Carlos and Tanya, okay, they have different methods for how they're going to subtract it in scientific notation, and the question is, how are their methods similar and how are they different? Okay, so we're going to do this like in 3 phases. So the first phase is you just going to be looking through these and trying to kind of identify the similarities and differences. Then we're going to do a partner share, and then we're going to talk about it all together. Okay, so the first part of that is just you thinking, you writing, you circling anything, whatever you got to do to kind of come up with your own answer. So how are these similar and how are they different between Carlos and Tanya? Okay, I'm going to give you a minute to just look it over yourself and try to kind of figure out what they did, what's similar and what's different. Okay, so this first minute, nobody's talking, nobody's sharing answers. You're just looking at these 2 different methods yourself and kind of trying to figure out what's going on. Okay, all right. You've got 1 minute, ready, go. All right, now you've had a minute to kind of think, write anything down, look those two methods over. So now it's time for the talking phase of this. So you are going to talk either in your group if you're sitting in a group or with your partner if you're sitting in a partner. Okay? Person number 2 is going to start the discussion, and then you're just going to go back and forth if you're in a partner and round robin if you're in a group. And you're going to talk about what did Carlos do, what did Tanya do, what was similar, and what was different. Okay? You're going to have another minute now to kind of talk and discuss. Ready, go. All right, your time is up. So now you've had 2 minutes overall. You've had a minute by yourself to look at this and then a minute to talk with your group about this. We're going to kind of look at this together and make sure everyone kind of noticed the important things. So let's just look at Carlos first. So it says, first I rewrote 2 and 28 times 10 to the 8th as 22 and 8/10 times 10 to the 7th. So he didn't change that number. He just made the mantissa more than 10, and then he dropped his characteristic or his exponent down 1 because he moved his decimal 1 place to 10 to the 7th, and then he set up the subtraction. And the reason that he did that, why he rewrote it, was so that he would have 10 to the 7th in both of the numbers that he was subtracting. Okay, and so then he subtracted 22 and 8/10 minus 5 and 8/10, and he got 17, and that was 17 times 10 to the 7th, because we know that from that previous problem we did that those exponents just stay the same. So if they're both 7s, then it stays 7 here. And then he knew, okay, that 17 is not, 17 is not an okay number to have as a mantissa, so he moved his decimal 1 place to the left, therefore adding 1 to his characteristic and ending up with 1 and 7/10 times 10 to the 8th. Okay, all right, that works. Then Tanya, she rewrote the Mercury standard scientific notation. She rewrote that as 5. She rewrote 5 and 8/10 to 58 hundredths times 10 to the 8th. So she instead bumped up the scientific notation to 8 instead of he bumped it down. Okay, and then she did her subtraction because she had 2 numbers with the same base of 10 to the 8th power. So then she took 2 and 28 hundredths and subtracted 58 hundredths and got 1 and 7/10 times 10 to the 8th. That was already in okay scientific notation, so she didn't have to do any work with her answer. Okay, so it's clear based on the problems that we did earlier and now with these 2 examples that the only way we can add or subtract is if we have numbers that have the same characteristic. They have to have the same exponent in the numbers in order for addition and subtraction to work. Once we have the same exponent, we can just add or subtract the mantisses. Okay, so there's a little extra step with adding and subtracting that actually makes them maybe a little bit more difficult than multiplying and dividing numbers of scientific notation. Okay, on the next page, 71, it says describe how to calculate the sum or difference of the 2 numbers written in scientific notation that have a different characteristic. Well, as we were kind of noticing there, um, we can't subtract or add numbers that don't have the same characteristic. So really what we have to do is, first and foremost, we have to make the numbers have the same characteristic, and then we can add or subtract. Okay, so we're not going to write any steps there right now, but I just wanted to draw your attention to this question so that we all remember that we have to convert it first. We can't. There's no trick for adding and subtracting in scientific notation until we have them in the same characteristic. Okay. All right, so on page 71, question 6 says calculate the sum or difference using any method. But we're going to use the method that we just learned, which is just keeping them in scientific notation. We're not going to turn them back into standard form. We're going to keep them in scientific notation and then solve. So the first one, letter A, is 3 7/10 times 10 to the 5th plus 2 1/10 times 10 to the 6th. Okay, so again, remember, the key thing here is these exponents. We've got a 5 and a 6. In order to add, we need the same exponent, the same characteristic. It's almost like when you're adding fractions, you have to have a common denominator. It's kind of the same thing here. We have to have the same exponent. Okay, so I'm going to go ahead and just convert the 3 7/10 times 10 to the 5th. I'm going to go ahead and convert that to 10 to the 6th. So we know that it's going to be 10 to the times 10 to the 6th power. We need to move our decimal to make that happen. Well, if we're moving it to the 6th, when we're working backwards, we really need to move it one place to the left. So we're going to get 3, 7, like that. So we're going to have 37 hundredths times 10 to the 6th plus 2 1/10 times 10 to the 6th. Okay, now we can solve this. We have the same characteristic. We have 10 to the 6th in both cases. So first step is to take the mantissa plus this mantissa. So I'm going to set it up as 37 hundredths plus 2 1/10. Add a 0 for placeholder. Make sure you line up your decimals when you do this. 7 plus 0 is 7. 3 plus 1 is 4. Bring your decimal down. 2 plus 0 is 2. So now we have 2 47 hundredths. Now all we need to do is bring down our 10 to the 6th, because again, that's not going to change. So it's times 10 to the 6th. And now we have our answer. Okay, so 3 7/10 times 10 to the 5th plus 2 1/10 times 10 to the 6th is 2 47 hundredths times 10 to the 6th power. Okay. So that was addition. Now letter B is subtraction. Okay. Subtraction works the same way as addition. So again, we've got a 10 to the 8th and a 10 to the 4th. So man, this one there's a big difference there. So we're going to need to move the decimal 4 times to get these to be the same. Now it doesn't matter if we convert them both to 10 to the 8th or convert them both to 10 to the 4th. So this time I'm going to go to the smaller number. So I'm going to convert 2 9/10 times 10 to the 8th and turn it into something times 10 to the 4th. Okay, so I know if I'm doing that, I need to move my decimal to the right because I'm really shrinking the amount of times that I'm going to move it when I get my standard form. So now I'm going to have 29,000, because I fill all those with zeros. So 29,000 times 10 to the 4th now, minus 1 4/10 times 10 to the 4th. Okay, now I have the same characteristic in both 10 to the 4th. So now I know I can just solve this like a subtraction problem. So just like I did with addition, I'm going to set it up making sure I line up my decimals. So I have 29,000 minus 1 and 4/10. I'm going to put a decimal there and add a 0. Okay. Now, I'm going to have to do a whole bunch of borrowing, but I have a whole bunch of zeros. So the first number that I can borrow from is this 9, so that's going to become an 8. That's going to become a 9 because I'm borrowing it to give it there. That's going to become a 9. That's going to become a 9. And now I have one that I can borrow to make a 10. So now I have 10 minus 4, which is 6. 9 minus 1, which is 8. 9 minus 0, which is 9. 9 minus 0, which is 9. 8 minus 0, which is 8. And 2 minus 0, which is 2. And we bring down our 10 to the 4th. And there we go. But, kind of like we saw yesterday, that is not incorrect scientific notation. So I'm going to have to do some more work here. I need to move this decimal 1, 2, 3, 4 places to make that mantissa between 1 and 10. So now I have 2 and 89,986 millionths times 10 to the 8th because I moved it 4 places. So now it's to the 8th. That is going to become my answer. All right, so you have 2 examples, one addition, one subtraction, and C and D are one subtraction, one's addition. So I want to give you guys a chance to work through those and come up with an answer, and then we'll come back and check. So I'm going to give you 3 minutes to work through C and D. Remember, you need to have the same characteristics, so you might have to change the numbers a little bit before you actually add or subtract. All right, you've got 3 minutes. Ready, go. All right, hopefully you've had a chance now to kind of work through C and D. So C is a subtraction problem, and I can tell right away that I have 10 to the fourth and 10 to the second, so I need to convert one of those. You're good, you can come in. All right, hopefully you've had a chance to work through letter C and D. So on C, we have 10 to the fourth and 10 to the second. So I know right away I'm going to need to change my characteristic before I can do any kind of solving. So I'm going to go ahead and convert the 10 to the second, the 3 and 1/10 times 10 to the second. I'm going to change that to 10 to the fourth. So this would then become 31 thousandths times 10 to the fourth. And now I have something that I can solve because I've got 2.5 times 10 to the fourth minus 31 thousandths times 10 to the fourth. So then I just need to do my subtraction, which when I subtract 31 hundredths from 2.5, I end up getting 2 and 469 thousandths, and that's times 10 to the fourth because that's what I had converted them to, and that becomes my answer because it's already in correct scientific notation. Now moving over to letter D, I have 10 to the 8th and 10 to the 7th. Again, I'm going to convert the 10 to the 7th to 43 hundredths times 10 to the 8th. And now I have 10 to the 8th here, 10 to the 8th here. And I can just do 9 and 1/10 plus 43 hundredths. And I get 359 times 10 to the 8th. And I'm done because, again, this is already in scientific notation. And so we're good there. Okay. All right, so now we've done addition and subtraction. The only thing that we have to make sure we're keeping track of is what our exponent is and making sure they're the same before we add or subtract. Yesterday we did multiplication and division, and so if you will go ahead and turn to page 73, I believe it's at the bottom of page 73, you have one of each. You have an addition, a subtraction, a multiplication, and a division. Okay. Now some of these are in standard form. Some of them are in scientific notation. So you might have to kind of move some things around, do some things, change some things. Okay. So I'm going to give you 4 minutes. That's a minute for each one to work through these A, B, C, D. Then I'm going to come back, check it. And then after we check it, I will wrap up this video and you will get your homework assignment so you can prepare for your quiz tomorrow. All right, so you've got 4 minutes now to work through A, B, C, D. Question 3 on page 73. All right, ready, go. Okay, time to check your answers. On page 73, you should have gotten these answers for A, B, C, D. Go ahead and I'll give you just a second to check and make sure this is what you got. And that concludes our video for today. Now you know how to multiply, divide, add, and subtract. We've done all four now. We added and subtracted numbers today written in scientific notation. You're going to get another short homework assignment like you did yesterday. This is due tomorrow. And don't forget, tomorrow, Friday, you will have a quiz over all four operations. So be ready when you come to class tomorrow to add, subtract, multiply, and divide scientific notation numbers. Okay? All right.